Hi, so this is the video showing how to calculate molecular formulas. So we shall look at the first question here. Determine the molecular formula of a compound if its empirical formula is C2H5O and its molar mass is 135.18. So we're given the empirical formula already, so this is already given in the question, which may not be given, but we know already how to calculate empirical formula. So we are going to find empirical formula mass, which I'm going to abbreviate as EFM, and that's just the molar mass or molecular mass, but of the empirical formula. That's why it's called empirical formula mass. So we're going to do 2 times 12 plus 5 times 1.01 for hydrogen. This is for carbon, and then 16.00. So that would be approximately equal to, this is 24, and I guess around 45.07 grams per mole, if I'm not wrong. And then we have our molar mass or molecular mass, same thing. Which is given to be 135.18 grams per mole. And so now what we have to do is so now we know the actual molecular mass or molar mass of the compound is 135.18. But our empirical formula is only 45.07. So we have to find how many times heavier our actual compound is. So to do that, we are going to do our molar mass divided by empirical formula mass, which gives us 135.18 divided by 45.07, which is approximately rounded to 3. And so what we have to do here is multiply all our subscripts by 3. So that becomes C6H15O3. And that would be our molecular formula now. Alright, so hopefully this is clear. First step, we find our empirical formula mass, given our empirical formula. Second step, we divide our molar mass by our empirical formula mass to get a number, which gives you how many times heavier the actual molecule is. And so third step, multiply all the subscripts in our empirical formula by that number here that we got to get our molecular formula. So I'm going to skip number 4 actually and go to number 5, because this is it's a 2-step process. So the first step, which we didn't have to do up here, that we do have to do, is actually calculate our empirical formula first. And we know how to do this, so we're going to go over that briefly. Element, mass, moles, mole ratio. So carbon, hydrogen, oxygen. Carbon is 48.38. Hydrogen is 8.12. It's given the rest is oxygen. To calculate oxygen, we have to do 100 minus the carbon minus the hydrogen. And what's left is 43.5%. And that would be our oxygen, but all these, we're going to convert all the percents to grams. And to calculate moles, we have our molar masses or atomic masses of these elements. And we shall divide the mass by the molar mass. So 48.38 divided by 12, 8.12 divided by 1.01, etc. And we get our number of moles. Oops. And then we are going to divide all the number of moles by the lowest number, which turns out to be 2.72. So divide everything by 2.72, which gives us a mole ratio of 1.5, 3, and 1. And because we have this 1.5 and I don't really like the 0.5s, it's not that I don't like them, it's just those are not appropriate in calculations. We're going to make this whole numbers by multiplying by 2, just to make that better. So now our empirical formula, the first step, which we have calculated, is now C3H6O2. So that's what we have calculated to be our empirical formula. So this is what we've done before. Now to calculate the molecular formula, we have to follow the 3 steps from above, which are namely, first step, empirical formula mass, or empirical mass, which we will calculate at 3 times 12.01 plus 6 times 1.01 plus 2 times 16.00, which is equal to 74.09 grams per mole. So we have first calculated our empirical formula mass. Now, first we calculated our empirical formula mass, which was 3 times 12 plus 6.1, 6 times 1 plus 2 times 16, which is based off of this formula here. We got 74.09. The second step, we're going to divide our molar mass divided by empirical formula mass, and we're given our molar mass as 148.12 divided by 70.09, and I'm going to guess this is approximately equal to 2. And so therefore, the third step, we know now our actual molecule weighs 2 times as much as our empirical formula, so we're going to take our empirical formula from above and multiply all the subscripts by 2, which gives us a molecular formula of C6H12O4. Right, and so this would be our final molecular formula. Alright, I will see you guys in class.